So we have already mentioned that when we compare multiple alternatives, we need to consider many factors. So here are some factors you need to consider. Those factors will make the options very different, and those differences are the things you need to compare for making a wise decision. So the first group of factor is operational performance factors. So, for example, if you want to buy a bicycle compared to a scooter, you want to compare their output capacity, like the speed, and the reliability, like which one is more reliable, and the setup time, which one is easier to set up and go, and also the fuel efficiency. So those are the things related to the operation of the two vehicles. Same thing to the equipment. Okay, so you also want to think about the output capacity, like how many products they make, and then what's the efficiency, how much time cost for each product, and then reliability, which equipment is more reliable, and the setup time, like how much time you need to install that equipment, right? And the fuel efficiency, or if it's equipment, maybe it's electricity efficiency. um, you want to know which one is more energy saving. So that's the operational performance factors you need to consider. And the second group of factors is called quality factors. So remember that we have mentioned in the early part of the class that so different equipment lines will give you different deficiency rate, right? So some equipment, they're low quality, so that the products it make will have more bad quality items. But if you want to have a higher quality products, you might want to spend more on the high-end equipment, right? So it's all related, the price and the performance. And then, so the quality factors um, are something you need to consider. For example, you want to buy a handhold saw and also table saw. So we all know that a table saw, it has many high technology involved. It even can be connected to a computer to decide the size and then the shape, and it's all semi manually operated. So there are less chance to have errors, right? So the rejection rate or the deficiency rate will be very low for the table saw, but of course it's more expensive than the handhold saw. So when you compare these two, you want to consider not only the operational performance factors, you also need to consider like what's the quality of the output from using these two different types of saws. And the third factors, the group of factors, is called the economic factors. Um, for example, the useful life, right? If you want to buy a car, sometimes you will consider the used car or the a new car, right? So you need to um, understand that the used car, although it's cheaper, but its useful life is shorter because it's already used by someone else. And so useful life is different, and the capital investment is different. Used car is cheaper, right? And annual expenses are also different, because used car, maybe it's already worn, and then it needs more repairment, and then more maintenance. But new car is brand new, so the maintenance fee might be lower every year compared to the used car. So the annual expenses are different, and also revenues. I mean, in this example, the revenues could be the benefits it gives you, like a new car is has more high technology, and then it's more comfortable than the used car. it's usually the new model. So that kind of benefit um, is something you can consider as a revenue. Or if you want to use the car to deliver the food in your restaurant, right? So the speed and then how fast you can reach your customers is giving you the revenue, right? So the faster you can deliver, the more customers you can serve in the same time window so that you have higher revenues. So that is an example of how they gave you the revenues. So these are the factors you need to consider when you compare different alternatives. And one comparison rules that is very important is the useful life and the study time of the project. They have to be the same. For example, if you are building a road segment and the timeline for that project is 6 years, and then you want to buy or lease some paving equipment, then those paving equipment could be used ones or new ones. And then they all have their different useful life. Like new ones, maybe the useful life is 12 years, and the old used one, the useful life is like 3 years. But your project timeline is 6 years. So all these years, the timelines are different. Then it's hard to make comparisons. So the first step or the first rule to make a apples to apples comparison is to make sure all the timelines will be stretched to the same number. And we will discuss the technique to convert the timelines to the same number in a later time. Okay, so before that, we need to discuss some new terminology like what is useful life of project. So, for example, a bridge designed for 50 years usage, so that 50 years will be the useful life. Or in the example we just mentioned, that road pavement project, you have to finish that first in 6 years. That's your contract time. So that 6 year is also your project useful project life. Oh, excuse me. So that 6 year of the project is your study period. It's not the useful life. So but if that road segment needs to be in good quality for 20 years, so that's the design life for that road segment, and that 20 years will be the useful life of that project. But that 6 year contract time will be the study period, because you are investigating the options just within that timeline. After that 6 year, you're not doing the same project, so you don't have to worry about the different options at all. So that 6 year contract time will be your study period. So by definition, study period is also called planning horizon, which is the selected time period over which mutually exclusive alternatives are compared. So usually we only compare the options within the study period. Okay, so for example, in the example we mentioned about the road project, we said maybe we want to lease a second hand um, pavement equipment, or we want to buy a new one, and then the used one useful life might be 3 years, and then the new one might be 12 years, right? But they are 3 years and 12 years are not 6 years as the study time. So um, if we want to compare these two alternatives, we need to somehow find a way to change the 12 years to 6 years and to change the 3 years to 6 years. so that they can compare. Okay, so the study period is usually it is the time length of your contract service, like in the road pavement project. Our contract is 6 years, so the study time is 6 years, or your construction project, or the time length needed for your construction project. Like if you want to construct a residential house, and then you know it's gonna be 1 year, so that 1 year will be your study period. Or the study period could be the length of your company's strategic plan. If you're a big company, maybe you want to make a plan for development for like every 5 years. So that 5 year will be your study period, and you want to consider all the new projects, the new investments for 5 years. And the study period could also be different from the useful life of a project, right? So the useful life of a project could be longer or shorter. Like the roadway segment, it could be 20 years long for service, right? But your construction project of that road segment could be only 6 years. Okay, so they're different. The study period must be appropriate for the decision being made. Okay, so the study period is, it should make sense for you to make the comparison. Like you know that your company maybe will be on the market for at least 10 years. And after 10 years, you are not sure if you're still in the same business or if your company is still running well. So 10 years will be the number you can, see through. So that will be the study period appropriate for you. But maybe for bigger companies like Apple, they want to dream for maybe 10 years or even 20 years. They're long visioned, and because their company is super gigantic, they know that even though they're not running well, they're not the company will be existed at least for 20 years. So they might will use 20 years as a study period. So you always want to use the study period that is appropriate for your case. And the useful life and the study period could be the same and also could be different. Useful life and the study period. So that's why we need to learn the later slides, because you're gonna face project life different from useful life of equipment, and also the different options has different useful lives. So that's the real case you usually see, and we will find a way to somehow convert all of the different timelines in the same time window so that we can compare apples to apples. And another terminology called repeatability assumption. So repeatability assumption assumes that the economic estimates for an alternative's initial useful life cycle will be repeated in all subsequent replacement cycles. Okay, which means, for example, if you want to buy a new equipment, but that equipment only works for 3 years, the useful life is very short, and you know that your project is gonna be 6 years. So after the first 3 years, you still need that equipment for the next 3 years, right, to finish the project. But how do you do that? The repeatability assumption assumes that you are going to spend the same amount of money to buy the same equipment again at the end of the third year. Okay, and then you're going to use that for another 3 years. So the life cycle of that equipment can be repeated, and in your case it's repeated twice. Okay, so that's the repeatability assumption, and this is very useful when we see some equipment's useful life is shorter than the study period. Okay, so we said if we want to compare different alternatives, we need to make sure that the study period is equal to the useful life of all the different options. For example, if you want to build a building like this, the concrete building, and your construction is 2 years, that's the contract time. And so to build this concrete building, you need a mixer. You need mixers, right? And to mix the concrete. And then, so you have two options. These are the two models of mixers, Model A and Model B. They have different operational cost. They have different performance. They have different use revenue and the benefits. So all the different factors you need to consider, but you need to consider them in the same timeline. And luckily, these two mixers, they all have their useful life of 2 years. Okay, so which means you can compare them directly. And also, these 2 years is the same as the study period. So this is a very easy comparison. You just draw the cash flow diagram for these two mixers within the 2 years, and then you convert every cash flow back to the present or to the future, or distribute it to the every year, and then you compare which number is bigger. Another scenario is the study period is different than the useful life, and the useful lives are also different. Okay. So for example, if you want to, your construction project is to build a road segment, and then your contract time is 6 years, right? And now you're looking for the paver. Okay, you want to buy a new paver, or you want to buy a used paver. Okay, so the used paver, its useful life is 3 years, and the new paver useful life is 6 years. So that makes the case complicated. They are different useful lives, so you cannot compare them directly. Okay, but how do you do that? Well, you need to somehow to convert the timeline into the same number of years, so that you can compare the MEAs over the same period of time. Okay, so for the first scenario, it's very easy. The study period equals to the useful life, and all the useful lives of different options are the same. Okay, so to do that, as what I said, you just use equivalent worth methods. You can calculate PW or AW or FW, right? And then you just compare which one is bigger. And if it is investment alternatives, you just find the bigger one, the more positive one as the good option. If it's a cost alternatives, which means your cash flows are all negative numbers, then you will find the least negative present worth or future worth or annual worth. That will be your better solution. Okay, and but you don't need to calculate all the PW, AW, and FW at the same time. You just choose one, and any one of them will give you the same answer. For me, I usually use the present worth. Okay, that's just a personal preference. You can also use annual worth or future worth to compare. So here is the example of useful lives equals to the study period. So here we have best flight in incorporation. It is considering 3 mutually exclusive alternatives for implementing an automated passenger check-in counter at its hub airport. Okay, so check-in counter, they might have different efficiency. Some counter may be working faster than the others, right? And they also may cost different price. So each alternative meets the same service requirements. They reach the same goal. But the differences in capital investment amounts, like how much you pay for each of them, and benefits, like how much you can save. So the study period is 10 years, and the useful lives of all three alternatives are also 10 years. So this is an easy case. Market values of all alternatives are assumed to be zero at the end of their useful lives. So after they're done their work, you don't sell them to any secondhand market. If the airline's MARR is 10% per year, which alternative should be selected in view of the cash flow diagrams shown on the next slides? Okay, so the diagrams are given in this problem, and so let's see what's the difference between these three options. So the first alternative A, at the beginning, you pay this much to buy the equipment, to buy that check-in counter, and then every year you can save 69,000 for 10 years. And option B, you need to pay more at the beginning to buy the system. And of course, every year you can save more. That's your saving is a receiving, okay? And option C, it's a price in the middle of the option A and option B, and also the savings or the profit you gain is also in the middle of the first and second option. So which one is the best alternative? Well, I just want to convert every cash flow to the present worth so that I can compare which present worth is bigger. And because these cash flows, we have negative ones and positive ones, so it's investment alternatives. So which means in the end, all the present worth will be positive, and you just choose the biggest one. Okay. So for example, for alternative A, the present worth has two parts. PW1, PW2. PW1 is from the present initial price, which is negative, you're going to pay, and actually you're converting the present worth to present worth, which means you don't need to convert at all. And the present and PW2 is from the annuities, it's positive, right? So you want to convert annuity to present worth. So this is our PW1, and this is how do we convert the annuities to present worth. So PW2, and after the calculation, this is your total PW for alternative A. So you want to do the same thing for alternative B and alternative C. And then this is the PW for alternative B. This is the PW for alternative C. So you want to compare which one has the biggest positive number. Obviously, it's alternative C. So C is the best. Okay. And scenario 2 is more complicated. We said the useful lives of the different options are also different. For example, these two pavers, one is useful life is 3 years, the other is 6 years. So how can we convert this different timelines to the same one number of years? So when the MEAs have different useful lives, there are several ways to proceed in order to compare the alternatives. Several ways. So if the repeatability assumption is applicable, like for example, the 3-year used paper, when it's done, when it's at the end of its useful life, you just pay the same price to buy the similar second-hand paper, which is also good for 3 years. That's what we said, repeatability assumption. Okay, and then it is good for another 3 years, so you can finish your project within 6 years. So if this repeatability assumption is applicable, then the study period is selected such that alternative occurs an integer number of cycles during the study period. Okay, which means you are gonna find a study period which is the least common multiple of the two study periods. Okay, so the least common multiple of 3 and 6 is what? Is 6, which means you're going to use 6 as your study period. And then how to extend the 3-year life cycle of the used paper to 6 years. You just need to, 0, 1, 2, 3, that's one life cycle of the used paper. You just need to extend it for another 3 years. But you need to pay the same amount. For example, if at the beginning you pay 10,000 for this paper, and the maintenance fee is maybe annuities as 500 every year, and then after the 3 years you're gonna pay the same amount for another used paper. So at the end of the 3rd year you're gonna pay another 10,000 for the same type of paper, and of course it will cost maintenance as 500 every year. So you see, you're repeating the pattern of this life cycle for another time, so that you can extend the 3 year to 6 years, and then you can compare this with this new paper. Okay, so here, what is the least common multiple? For two integers, a and b, denoted LCM, so LCM is least common multiple, will be the smallest positive integer that is evenly divisible by both a and b. If you don't remember how to find the least common multiple, please go and review your math book. Okay, so for example, for 2 and 3, the LCM is 6, because 6 can be divided by 2 evenly, and it also can be divided by 3, right? And another example is the LCM of 6 and 10. It's 30, because 30 can be divided by 6 and you can get an integer out of it. And it also can be divided by 10 and you can also get an integer by as a result. Okay, so this is what we call the LCM. And so if you have two different or multiple different useful lives, you need to find out the LCM of those number of years, and then use that as your study period, and then extend the shorter useful life by using the repeatability assumption. Okay, so now let's look at this example. So the following data have been estimated for two mutually exclusive investment alternatives, A and B, associated with a small engineering project for which revenues as well as expenses are involved. They have useful lives of 4 and 6 years. See, for option A, the useful life is 4 years. Option B, useful life is 6 years. So the useful lives of these two options are different. And the MARR is 10% per year. And which alternative is more desirable? Okay, so they want you to use the repeatability assumption, which means you need to find the LCM of 4 and 6 first. What is that? It is 12. Okay, so 12 years is gonna be your study period. And now you can use the repeatability assumption, which means you can extend the option A by repeating the cycle of 4 years for 3 times. So 3/4 is 12, so that you can extend the timeline of this option to 12 years. And for option B, you can repeat the cycle by twice, okay, by 2 times, which means 2 6 years will be 12 years. So that's the method we're going to use. Okay, so let's divide this to 2 parts. And for A, okay, so let's just draw the first 4 years. We know that at the beginning you need to pay 3,500 to buy the equipment maybe, and every year you have annuities of 1,255. Okay, and then we said we want to use the study period as 12 years, which means you need to repeat this cycle for 3 times. So 5, 6, 7, 8. This is another cycle, but you need to pay the same price for the same equipment. So you need to pay at the end of the first cycle, you need to pay the same 3,500 for the same equipment. And then every year after that, you're gonna have the same annuities. Okay, and then you're gonna extend another time. So that the whole timeline will be 12 years, okay? Which means at the end of the second cycle, you're gonna pay the same price to buy a new equipment, and then after that, every year you're gonna have the same annuities. Well, this is how you extend this shorter timeline, shorter useful life to the study period using the repeatability assumption, okay? And then now it's option B. The first cycle is 6 years. At the beginning, you want to pay more. That's more expensive equipment. But every year your annuities will be greater, which is 1,480. And you want to extend this for another time so that you can reach the 12-year study period. Okay. Which means at the end of the first cycle, you need to pay the same price for the same machine. And after that, every year you're going to have the same positive annuities provided by the machine. Okay, so this is how you use the repeatability assumption to extend the shorter useful life to a longer study period. Okay, And then you just need to convert all the cash flow to the present worth and compare the present worth of A and the present worth of B to see which one is bigger. Okay, so to convert the cash flows for A to present worth, you need to see, you want to have the present worth A. It consists of several parts. So PW1 is from the first 3,500 at the time 0. And you want to convert the present worth to present worth. PW2 is the other 3,500, but it's at time 4. So it's a future value want to be converted to present value. PW3 is the third 3,500 you paid at time what? Time 8. So still it's a future worth converted to present worth. And the PW4 is all the positive annuities. Okay, for how many years? 12 years. So it's to convert the annuity to present worth. Okay, and then you just need to calculate the PW1, PW2, PW3, and the PW4. Okay, PW1 you don't need to convert because it's already present value. So just copy that value here. PW2 you need to use the formula convert future value to present worth is F times P/F MARR and N. So that is 3,500 times the P/F 10%. How many number of years? It's from the time 0, it is 4. Okay, so I will skip the calculation. Okay, I'll just write down the formula. PW3, still it's a future value converted to present worth, so the formula is the same. But the difference is the time, that how many years you want to, consider is different. It's from the end of the 8th year. Okay, so the number of the value of N is gonna be 8. PW4 is positive A P/A MARR N. Positive 1255 P/A 10% 12. Okay, so after you find out the factors and the calculation, you're gonna have the PW equals to the sum of these 4 parts. And the final result is positive 1027.9435. Now let's do the present worth method for option B. Okay, so you wanna have the PWB, and it's consists of 3 parts. PW1 is from the initial payment at time 0, so it's P converted to P, and the PW2 is another 5,000 at time 6, so it's a future value converted to P. And the PW3 is the positive annuities for 12 years. So it's to convert annuity to present worth. And then you need to calculate what is PW1, what is PW2, what is PW3. So PW1 is 5,000 negative. PW2 is to convert a future value to present. So its formula is F times P slash F MARR, and it's 5,000 P slash F 10%. How many years you need to consider? It's this value. It's at the end of the 6 years, so the N is 6. PW3 is to convert the annuities, so the formula is A times P slash A MARR N, so it's positive 1480 times P slash A 10% 12. Okay, so after you calculate all of this, you're gonna find out PWB is the sum of PW1 plus PW2 PW3, and then the final result is 2261.776. Okay, so compare these two values. Which one is bigger? Of course, the PWB. So PWB is bigger than PWA. So you want to choose B as a better option. Okay, and so more complicated case will be useful life bigger than study period. So if useful life of an item or of equipment of an option is bigger than your study period, what you can do? The most common technique is to truncate the useful life at the end of the study period and use an estimate of the market value any equipment used. So this assumes that any remaining equipment or supplies will be sold at market value at the end of the study period. Okay, let's say if your item is good for 8 years, but your study period is only 6 years. Okay, so how do you do that? By this method, it means you truncate at the end of the 6 years, at the end of the study period, and you assume that you will sell this equipment to a market, so you have a salvage value as receiving at the end of the study period. Okay, so you don't have this at all. Okay, so that's the first method. And the primary objective of these various techniques is to compare MEAs over the same period of time, over the same study period. Okay, so all you need to do is to truncate the long useful life of an equipment, and by truncating it, you have to assume that you will sell it at the end of the study period. Okay, and you will add this salvage value in your cash flow diagram so that you can compare all the different options. Okay, don't forget to add this salvage value at the end of the study period. Another thing is useful life of an item could be smaller than study period. right? So the different options for comparing alternatives, when one option has a useful life less than the study period is, you can contract the service or lease the equipment for the remainder of the study period. For example, if your study period is 6 years, but your equipment option useful life is 4 years. Okay. So how do you extend that 4 year to 6 years to compare? You can assume that after 4 years, you're gonna contract the same service to another person, or you can lease the equipment for the remainder of the study period and incorporate these costs into the comparison. Okay, so for example, this is the 0 to the 4 years. So for the equipment, you might pay some dollars at the beginning, and then you have maintenance fees. Okay, and then you're gonna assume that at the end of the 4 years, you need to lease, for example, a new one. So for leasing, you need to pay another amount, and then you can use for another 2 years. And every year you might have, if it's a leasing, then you don't have to pay for the maintenance. The company will pay that, right? So you don't have any cash flow. But you just want to, add this leasing fee on the cash flow diagram. And then you can compare this with another, 6 year useful life options. Another method to handle this situation is you can repeat the course of action for a part of the useful life and truncate at the end of the study period using an estimated market value at the end of the study period. Which means if you have equipment good for 4 years and your study period is 6 years, okay, so how can you extend the 4 years to 6 years? You can extend it by repeatability method for another cycle. So it's gonna be 8 years. And then you go back to truncate it at the 6 years. And then you sell this equipment at that time to the market. And then you're gonna add that salvage value at the end of the 6 years. Okay, so you extend it for another cycle using the repeatability method, and then you truncate it. The third method is you can reinvest all cash flows starting at the end of the useful life until the end of the study period. Still the same example. So say your item is good for 4 years, your study period is 6 years, okay? So the way we do that, the third method is you have all the cash flows for this item in the 4 years, right? In the useful life. And then you convert all these cash flows to the end of the 4th year. We call it F4. Okay, so that's the future value of all the cash flow at the end of the useful life. And then you reinvest this F4, the value, the total value, into something else. Something else for how long? For 2 years. So that it can be extended to the 6-year study period. And then because you're going to reinvest it, so you have to know what is the interest rate. So the interest rate for the 2 years is still the MARR. Okay, so that's the third method. The fourth method is to replace the item with a different item, which possibly has different cash flows for the remainder of the study period. So you just, after the 4 years, you just the first equipment retired, and then you just buy a new one. That new equipment could be different than the first one, different price, different cost of maintenance. So it doesn't matter as long as it can last for another 2 years to reach the 6 year study period, it's fine. Okay, so these are so many methods you can deal with this situation. And now the common one is we just use the third option, the third method. And now let's take a look at the same example of that the 4 year and 6 year projects we just solved. Okay, so the same thing. Let's go back to check that example. So here we have two options, A and B, and the useful life is 4 and 6. Okay, and we decide that, okay, let's use the 12 years as a study period so that it's at least a common multiple of 4 and 6. And another method of doing that is, of handling this problem is, okay, so we can just say the study period is 6 years instead of 12 years. Perhaps this is determined by the manager who does not agree with the repeatability assumption, and the manager wants to handle or consider the situation just within 6 years. Okay, so many reasons why we want to use 6 years instead of 12 years. So now the study period is 6 years, and how can we extend the 4-year option A to 6 years? Okay, so we said we want to use the reinvestment method to deal this situation. To deal with this situation, okay? So the reinvest method. So now let's divide this to two parts. So for A, that's more complicated, right? So let's just draw the 4 years timeline. So at the beginning, you pay $3,500, and every year after that, you save annuity as 1255, right? And the way we can extend this 4 year to 6 years is we convert all the cash flows to the future time as F4. Okay, FW4. Okay, and then after that, we reinvested this at something else. We don't know, but we know that the interest rate is 10% as the MARR. Okay, so we want to convert this to FW6. Okay, so which means we want to convert the cash flows at the end of the 4th year to a future time at the end of the 6 years. Okay, so the first thing is you need to convert all the cash flow of the 4 years to the FW4. So FW4, don't confuse, this 4 means at the end of the 4th year. It doesn't mean the part 4, okay? So let's just write it as we don't want to confuse ourselves. So we just write it as FW fourth year and FW sixth year, okay? So FW fourth year, we need to convert to the two parts. Part 1 is the 3,500 negative at time 0. So it's to convert a present value to a future value. And FW, the part 2 is the positive annuities for 4 years. So it is to convert A to F, right? So FW fourth year will be the total of FW1 plus FW2. So I'll just write it directly without listing all of them, individually like before, okay? So FW1 is negative 3,500. FW2 is positive. By formula, it's gonna be A times F slash A MARR N. A is 1255. The factor is F slash A, 10%, 4, right? And then this value is gonna be positive 700.105. And now we want to convert this value to the future time at the end of the 6th year. So we want to have FW6 year, which is gonna be, so the FW for the 4th year compared to the 6th year, it's present worth, right, relatively. So the formula is P times F slash P MARR, because we know it is still at the MARR interest rate for the new reinvestment. But the time, it's just 2 years, okay? So the N is 2. So the P is 700.105 times F slash P MARR 2. No, it is 10%. So the final result is 847.12705. Okay, now let's do the option B. That's easy because option B is already 6 years, so you don't have to do any method to extend or truncate. Just draw the timeline. At the beginning, you want to pay 5,000, and after that, every year you have annuities, positive annuities, which is 1480. Okay, so now you want to convert everything to the future so that you can compare the FW6 year with the first option. Okay, so now we're just to use the future worth method. Okay, so you know the FW 6 year consists of FW1, which is from the negative 5,000, okay, at a time 0. So it's to convert P to F. And FW2 is from the positive annuities of 1480 for 6 years. So it's to convert A to a future value. Okay, so FW, the same, 6 at the end of the 6th year is FW1 plus FW2. That's the two parts. So FW1 is negative, and because it's to convert P to the future, so the formula is P times F slash P MARRN, okay? And FW2 is annuity positive, so it's A F slash A MARRN. Okay, so I'll just write it here. So it is negative 5,000 F slash P 10% 6 plus 1480, that's the annuity, times F slash A 10% and 6. So if you check these factors and do the calculation, your final results will be positive 2561. Okay, so the comparison tells you this number is bigger. So the plan B or the option B will be the better one. Okay? Because FWB is bigger than FWA. So B is better. Okay, so that is all for today.